Hello ladies and gentlemen, welcome back. This video is going to be for students who are in Algebra 2 Goal 3. Again, the vast majority of students who are in Algebra 2 Goal 3 are almost done with the goal, which is why I'm starting with topics on the back end of the chapter and then kind of going in reverse order. What we're looking to do here, this is for students who are trying to round out. They've already done the exponential growth and decay ones. They know the topic for them. They know what to do for them. And now they're trying to figure out, okay, miss, I'm at like 80, 83%. I just need one or two more topics. So first things first, both topics that I want to show you is a DSA are DSA topics. You need them for the DSA. And then one topic in particular, you require a different topic in order to unlock it, and I will be showing you how to get to that topic as well. So it's 2 questions on the DSA and then one that unlocks one of your DSA questions. We will start over here with finding first terms in a sequence. This is question, I think, like 16 or 17 on the DSA. And it's not, a lot of kids struggle with this topic. It's not overtly hard, but it is time consuming. And if you're not comfortable with order of operations, this can get painful after a while. But what's happening here is that you see you have an n here and an n here. What's going to happen is, over the course of this, you're going to take this entire piece of math and you are going to replace each of those n's with a 1, a 2, a 3, and then a 4. Because we're finding the first 4 terms in the sequence. So what does that mean? This will be -1 to the first power, and then this will be over 3 to the times 1 plus 4. This will be -1 squared over 3 times 2 plus 4, and so on and so forth down the line. That's what you're going to be ultimately doing. The big thing here is this topic comes in a lot of different flavors. You can already see the next one here looks completely different than the top one. And because it always visually looks different, students are always just intellectually confused on, if it looks different, does that mean what I'm doing is different? And the answer ultimately is going to be no. So if we look at this, the thing to keep in mind, that is -1 to the first power, which means that there's only one -1 there. That leaves us with -1, 3 times 1 is 3 plus 4, 4, so that will be -1 over 7. This one, -1 squared, that's -1 times -1. Negative times a negative is a positive, so that's +1. 3 times 2 is 6 plus 4, so we're going to have 1 over 10, okay? Comma, comma. This one will be -1 cubed over 3 times 3 plus 4. What does that mean? So this means that there are 3 -1s here. Or, oops, nobody saw that. That didn't happen. I was misquoted. There are 3 -1s here. There we go. We know this made a positive. What's a positive times a negative? -1 over 3 times 3, which is 9 plus 4. So this will be -1 over 13. And what's happening here, comma, is that this then is going to be what's going in the answer box when you're doing this out. So -4, -4, that was a mistake. When you have -1 to the 4th over 3 times 4 plus 4, so -1 to the 4th power, that means that there is 4 of them. I almost made a mistake again. This together makes a positive. Positive times a positive is a +1 over 3 times 4, which is 12 plus 4. So this will be 1 over 16. And that's our list. So the big takeaway for this particular problem is to be very careful of your exponents. -1 to some kind of exponent, if you kind of notice, first you got a negative, then you got a positive, then you got a negative, then you got a positive. That's ultimately what it's trying to do. And most 90% of problems students have with this topic is with that exact moment. But we'll go through a couple of others to make sure that we're comfortable. Let's see here. We have exponent again, n plus 1, and it's a -1 again, so we're going to be careful of our signs. And then we have n squared. So 1, 2, 3, 4. So we have -1 to the 1 plus 1 times 1 squared. -1 to the 2 plus 1 times 2 squared. Negative 1 to the 3 plus 1 times 3 squared. Negative 1 to the 4 plus 1 times 4 squared. Okay, so 1 plus 1, that's negative 1 squared, times 1 squared is 1. So squared, here's a trick for you. For those of you who are dealing with negative 1 exponents, if you have negative 1 to something, if it is even, it is positive. If it is odd, it is negative. And I just went through the effort of proving that when I was doing it out in the long form up here. So this is negative 1 squared. Squared, that's 2. That's an even number, so this is 1 times 1, which is 1, comma. What's our next one? 2 plus 1 is negative 1 to the third times 2 squared, which is 4. So negative 1 cubed. 3 is odd, therefore it's negative. Negative 1 times 4, negative 4. And you can kind of already see that you're alternating your signs again. 3 plus 1 is negative 1 to the fourth times 3 squared, which is 9. All right, that's even. Even is positive. So it's going to be 1 times 9, which is just 9. Then it's negative 1 to the 4 plus 1, which is 5, times 4 squared, which is 16. 5 is odd, therefore it's negative. Negative 1 times 16, which is, of course, negative 16. And you can kind of see the topic itself, the work you're doing isn't that hard. You can do all of your computations in about 2 to 3 lines. The part that makes it difficult is that it's kind of long because you're doing it from 1, then 2, then 3, then 4. You need to remember little tricks here and there. If you're weak on order of operations, like there's a lot of compounding problems for this particular topic. One more. We'll end off on a slightly easy one, and I just now realized I didn't give myself enough space. So we have our 1, our 2, our 3, and our 4. I'm going to have to write really small. So that's our n, and that's our n. So 3 times 1 over 5 times 1 plus 1. So that's going to be 3 times 1 is 3. 5 times 1 is 5 plus 1, which is 3 over 6, which is 1/2. The computer doesn't technically nitpick you if you don't reduce your fraction, but I always recommend that you reduce your fraction. It makes life easier for you. Then this will be 3 times 2, and then it'll be 5 times 2 plus 1. What do we get? So 3 times 2 is 6. 5 times 2 is 10 plus 1, so that'll be 6 over 11. That's another answer in our box. Then 3 times 3 over 5 times 3 plus 1. 3 times 3 is 9, and then 5 times 3 is 15 plus 1, so this will be 9 over 16. There's my next one. Last up, it will be 3 times 4 over 5 times 4 plus 1. 3 times 4 is 12 over 5 times 4, which is 20 plus 1, so it is 12 over 21. And that's how this topic is done, rapid fire in quick succession. Again, nothing that you're doing is hard, but it's a lot of little things, and the mistakes can start to compound after a while. So be very careful. Don't rush this. Take your time, write out your little tricks if you need to so that you don't forget them after the fact, okay? Next one. The next DSA question is this one, but 90% of my kids, when they're trying to go for it, it is locked. So instead, we're going to look at this one. This particular one unlocks the DSA topic, and you're doing ultimately exactly the same thing for both this topic and then the other one. So what's going to happen is, let's see if I can scroll down. There we go. We're going to make a quick little table, -2, -1, 0, 1, and 2. And then what's the function? The first one we have is going to be 7/8 times x cubed. What's happening here is because you have the x cubed and exponents come first, that's what we're trying to train you for in goal 3. That's one of the big keys that we're doing. What we're doing is we're taking each of these, because this is our x values. You know, it's going to be -2, comma something, -1, comma something, 1, comma something. Is we're going to be cubing all of these. And in the act of cubing these, you're going to see a pattern here, and that will actually make the math for this a lot faster. So let's go through this. Negative 2 cubed, or actually no, I'll start on the positive number, so that's a little bit easier. Negative 2 cubed, that's 2 times 2 times 2, so 2, 4, 8. So our answer here is 8. Well, what if it's negative 2 times negative 2 times negative 2? Negative 2 times negative 2 is positive 4, and then times negative 2 is negative 8. And automatically, at a glance, I can see what the pattern is going to be when I'm doing this. 1 cubed, that, 1 cubed is 1 times 1 times 1, which is just 1. And then we were talking about up here already what happens when you have a negative 1 for an exponent is if you have negative 1 times negative 1 times negative 1, your answer is negative 1. And then 0 is always going to be 0. And you can see the numbers are the same. The numbers are the same. It's just that the signs are flipping. That's the thing you're keeping in mind. And then the last thing that you need to do, part 2, is you're going to take the 7/8 and you're going to multiply it. So 7/8 times 7/8 times 7/8 times 7/8 times 7/8. And this is where the software is actually legitimately nice to you. Every single time, whatever fraction they give you up here, it will divide evenly with your negative 8s to make life easier for you. And again, worst case scenario, you have this button in the software and it will be able to allow you to put in fractional coordinates, which we'll see in a second. So moving our way down the line, we have 8 times 7/8. The 8s disappear because one's in the numerator and then one's in the denominator, so you're left with negative 7. And then by default, I'm not even going to do the math. I know this is going to be positive 7. Any number times 1, I said that backwards. Any number times 1 is itself. So if this is 7/8, then this is going to be 7/8. And then any number times 0 is going to be 0. That's our y. So what we have now is an actual coordinate, negative 2, comma, negative 7. We have negative 1, comma, negative 7/8. We have 0, 0. We have 1, 7/8. And then we have 2, 7. That is absolutely doable and graphable. So negative 2 to 7. And of course, the one time I choose something from the internet, it's the wrong thing, of course. It's going to be about there, negative 2. And then negative 1 is going to be 7/8, so that it, nope. Did you see the mistake I just made? I forgot my signs. This is negative 2, negative 7. And then it's going to be negative 1, negative 7/8, so about there, 0, 0, 1, 7/8, and then 2 to 7. And you can start to see, you know you will have done it right when you have basically that sideways curve. Doesn't matter which way it's doing. If you get that curve, then you are correct. If you don't get it right, then you've made a mistake. Usually 9 times out of 10, if kids are making a mistake, they input it wrong when they were doing it out. More rarely, especially if they're doing it in their heads rather than on a calculator, they're getting a mistake when they're doing the computation, okay? So that is one example for this topic that unlocks a DSA topic. Let's go through a secondary example. So let's just go through and delete like 90% of this. All right. Delete. Deselect. What's the next one that we have? We have negative 1/2 x cubed. So we're going to get negative 8, negative 1, 0, 1, and 8. And now we're multiplying it times negative 1/2 times negative 1/2 times negative 1/2 times negative 1/2 times negative 1/2. All right, so 8 and 2 divide evenly. So 8 divided by 2 is 4. What is negative 4 times negative 1? Positive 4. So my first one is negative 2, comma 4. And then based on that, I know automatically this will be 2, comma, negative 4. Because it's the same thing, it's just that the numbers flip, but we'll double check. So 8 divided by 2 is 4. 4 times negative 1 is negative 4. And we're right. Okay, so 1 times any number is itself. So that will be 1, comma, negative 1/2. That makes sense. So this will be negative 1, comma, positive 1/2. And we're starting to see the pattern here. And then we have 0, 0. So negative 2, comma, 4, negative 1 comma 1/2, 0, 0, 1 comma negative 1/2, and then 2 comma negative 4. And there's your curve. And you're starting to realize that because this is so repetitive, it's actually not that bad when you're going through the math. The two graphing topics, this one and then the actual DSA one, are actually on paper very, very simple to do. There's a little bit of a learning curve just in the sense of kids getting used to this and the pattern recognition, but generally speaking, once that clicks in their head, it goes by really fast. One more example to make sure we're good. What's our last one? 3/4 x cubed. So we know we have -8, -1, 0, 1, and 8, because that's what our cubing is going to be every single time. And then it's going to be times 3/4 times 3/4 times 3/4 times 3/4 times 3/4. Okay, 8 divided by 4 is 2, so -2 times 3 is -6. That means this is +6. -1 times 3/4 is -3/4, therefore this is +3/4, and then that's going to be 0. So we have our coordinates, -2 comma -6. We have -1 comma -3/4. We have 0, 0, and then we have 1 comma 3/4, and then we have 2 comma 6. So -2, 6. 1 at -1. Nope, I did it again. I'm so focused on the number, I'm not looking at the signs. -2, -6. -2, -3/4. So about there. There, 1 and 3/4. And then 2 and 6. And then there is your S curve. Now, when you do the math out for this, it is almost shockingly similar to the next topic, the one that's the actual DSA topic. So let's take a look. Didn't quite give myself enough space on this side, but we'll do what we can. Again, we're going to go -2, -1, 0, 1, and 2. Let's see here. What's our first one? We have -2 to the -x. All right. Now this one, we don't have that sort of base of -8, -1, 0, 1, etc. We actually do have to do the math out for this, but that's completely doable. This is 2 to the -2nd power, and this is from a different topic. Negative exponents. So where can I write this? Negative exponents mean you flip your fraction. Flip your fraction. So what this means is this isn't 2 to the -2. This is 1/2 squared. 1 squared is 1. 2 squared is 4. And there is our answer. So this will be -2 comma -1/4. That's going to be our coordinate. Now there actually is a pattern here, and I want to show it to you. So I'm going to skip all the way down to the 2. This is, wow, I made a mistake. Okay, let me go back. It's not -2 that I'm plugging in. It is -2, because it's negative x. And what's our x? -2. Double negative is a positive, which means this actually does not get flipped, because this is going to be just 2 squared, which is just going to be 4. And I just gave the game away by showing you what the next number is going to be, because this will be 2 comma -1/4. All right, let me do this again, only a little bit slower, keeping track of my math so that this makes sense, because I made a mistake and I want to make sure that I'm showing you guys correctly. We have -2 to the -1. That's what this -x does. That's the whole point. That's what they're trying to sell you on. And when I grabbed my equations, I deliberately grabbed ones that had negative exponents, because a lot of kids kind of struggle with this at first blush. So what's happening is it's -x. So you're going to be writing negative and then whatever your x is. And in this case, what's your x? -1. That's why it's -1. Double negative is, of course, a positive, so that's -2 to the first, which is just -2. So our first one is going to be -2. And there is a pattern here. I'll show it to you. So this will be -2 to the negative, what's my x? Plain old 1, which becomes, flips your fraction, so that's 2 over 1. It flips to 1/2, and then we slap a negative in front of it. 1 over -1/2. And now we can start to see the pattern. 4, 1/4, 2, 1/2. Your fractions are flipping, where over here the sign was flipping, so you can see 6 and -6. Here, your fraction is the thing that is flipping. We go from 4 over 1 to 1 over 4. That's the thing. And then, of course, classically, anything to the 0 power, it was an earlier topic, you should know it is. Dramatic pause. Oh, I heard somebody say it. It is, in fact, some version of 1. So this will be 0 and -1. Now, when I look at the graphing, this will be fun. We have -2 and then -4. I looked at the sign this time. Aren't you proud of Ms. Dubois? Then it's -1, -2, 0, -1. And then we have 1 and -1/2, and then 2 and -1/4. And if you start to see a curve that looks like this, there's one other thing that you got to keep an eye out for, and that is going to be this button in the software, because what you want to make, and I'm going to use a fancy math word here, is you want to make an asymptote, okay? That's what this means. This is an asymptote. Isn't that obnoxious to spell? We're going to, for this topic, they're going to try to play you because they have both a vertical and a horizontal asymptote on the software. The horizontal one is the only one we want, and we only want to put it on the x-axis, okay? Only want to put it on that little dotted line on the x-axis. In the grander scheme of math, you can have an asymptote basically anywhere, and that's actually one of the coolest parts about, abstract algebra and the more higher end math. But for the sake of just this topic, you're only putting it on the x-axis. Only then can you hit the graph button, and you will get a curve that looks like this. And that's how this topic is going to be done. Where over on this topic, you needed that kind of S-curve. Here, you want that exponential curve, the stuff that you were doing in some of your exponential growth topics from the other video. So let's go through the effort of erasing this entire mess and starting fresh. Bleep. So -2, oops, I didn't give myself enough space. -2, -1, 0, 1, and 2. And this time it is 3/5 to the negative x. Negative x, Ms. Dubois, you want to make absolutely sure you remember that. So this will be 3/5 to the -2. That's what it's doing. So double negative is a positive, so this will be 3/5 squared, which is going to be 3 squared is 9. 5 squared is 25. So our answer is going to be -2, 9 over 25. Now, if we recognize the pattern, that means this will be 2, 25 over 9. Oh God, I'm going to hate graphing this. 25 over 9, let's double check. We have 3/5 to the -2 because it's opposite of the sign. So then that means it flips. Negative exponent means you flip your fraction, and then square it, and then 5 squared is 25, and then 3 squared is 9. So it ended up being right. We're good. Next, it'll be 3/5 to the -1. Double negative is a positive, which means you're just going to get 3/5 as an answer, which means this will be 5/3. So it'll be -1, 3/5, and then it will be 1, 5/3, okay? And then 0, anything to the 0 power is some version of 1, and since all of my numbers here are positive, it will all be positive here. So -2, and then 9/25. That's so small, I'm not sure I can graph it. It'll be something like that. Then for -1, it will be 3/5, so a little over the halfway point. 0, 1. 1 is 5/3, so about there. And then 25 over 9, what even is that? That's a little over 2 and a half, so something like that. We're going to put in our dotted asymptote. I regret having the line being black because you can't really see the graph, the asymptote as I'm making it. And then your graph is going to look something like that. once you do it out. And the good news is, because you're doing this in the software, this is the love part of the love-hate relationship, it actually graphs really neatly for you. And we can see we have that exponential curve, which means we're on the right track. Okay, last one, and then we'll consider this video complete. Let's see here. -2, oops, brush tool. -2, -1, 0, 1, and 2. What do we have? We have -2 fifths, -2 fifths to the negative x. So it's -2 fifths to the -2. Double negative is a positive, which means the fraction stays the same. So that's 2 fifths squared. 2 squared is 4, 5 squared is 25, and then it's negative because we slap that on at the very, very end. So we have -2, -4 over 25. And then I'm speed running this now a little bit because I know the pattern very confidently. So it's going to be 25 over 4. Now this will be 2 fifths to the -1. Double negative makes a positive, which means we just have 2 fifths. Okay, so this will be -1, -2 fifths. That means this will be 1, -5 over 2. All right, and then anything to the 0 power is some version of 1, and since all of these are negative, the 1 here will be negative. All right, not so bad, not so bad. And this is what a speed run, as you get comfortable with this topic, that's how fast you can do it. You're technically finding 5 points, but you only really need to do the work for 2 of them, and that's one of the ways that you can make this topic a little bit easier, especially if you're really good with your pattern recognition. So, -2, oh wait, asymptote first. Let's draw our little asymptote. I promise it's there. All right, so now what do we have? We have -2 and then 4 over 25. That's even smaller. Something like that. -1 is 2 fifths, really low, and then it's 1. And then 5 halves, that's 2.5, so that's like way up here. And you can see how sharp your curve is, starting to see. And then, oh, wait, negative, Ms. Dubois, look at your signs instead of the fractions, Baka Sensei. All right, so it's -4 25ths. And then it's -2 fifths, so really still kind of low. And then we jump to -1, and then we jump to 2.5, and then 25 over 4, that's 5 something. So 5 1/4, so something like this. And now you can see the exponential curve. So Ms. Dubois is making a couple of mistakes because she's so focused on graphing the fractions, she's not looking at the signs. For you guys, because you're inputting into a computer, that will actually make it easier for you. So that's the last of the major DSA topics that we have to worry about. All of these have now been done, and we got a bonus topic just so that we can get everything unlocked in order to get what we are looking for. So since most of my kids who are in Goal 3 are almost done with it, hopefully these 2 video tutorials will help you, and I will see you in the next one. As always, stay happy, stay healthy, stay safe.